All right, on 1 through 6, you're classifying each pair of angles. So we got angle 1 and angle 3. Angle 1 and angle 3 are alternate interior angles. And so that's choice E. The next one, 3 and 4. 3 and 4 are right next to each other. Together they form a straight line. So that's linear pair. Then we have 1 and 6. 1 and 6 are vertical angles. They're opposite angles formed by intersecting lines. We got 1 and 8. 1 and 8 are alternate exterior angles. They're on the outside of the two lines and alternating sides of the transversal. 6 and 7, same side interior angles. They happen to be supplementary. And then 5 and 7, those are corresponding angles. They're in the same position to the transversal and one of the parallel lines. In this case, below the transversal to the left of one of the parallel lines. And those are congruent, by the way. I'm going to use the same diagram for number 7. Angle 1 and angle 8, those are alternate exterior angles, and those are congruent. So their measures are equal. So we can write 5x plus 5 equals 4x minus 21. Because they're alternate exterior angles. I should have, I guess I'll draw it in there. Those should be, I should have given you that those were parallel. So since they're parallel, then the alternate exterior angles are congruent. So their measures are equal. You can get your x's on one side, constants on the other side, and divide by the coefficient. Yeah, I'm going to fix this on the printout version. I'll fix those signs so that it'll come out to be positive. Sorry about that. All right, so the x comes out to be positive 26, and then you can plug it back in to find the measure of angle 1. It's equal to 5 times x, 5 times 26, minus 5. So that'd be 130 minus 5, 125 for the measure of angle 1. Goal here was to find x. We found that to be positive 26. And then we also found the measure of angle 1 to be 125. Again, I'll fix those signs. All right, number 2, measure of angle 2, on 8 is 49. So this is 49 degrees. Trying to find the measure of angle 3. Well, 2 and 3 are same side interior angles, so they add up to 180. They're supplementary. And so one of the angles is 49. To find the other angle, subtract 49 from the 180. So we found the measure of angle 3 to be 131. Number 9, we've got vertical angles here. Vertical angles are always congruent, so their measures are equal. You can subtract 2x to get the variables on one side, and then we'll subtract 5, or add 5, excuse me, to get rid of the minus 5. We found x, we can plug that back in to find the measure of each of these angles. So 3 times 37 minus 5. So 3 times 37, let's see, 3 times 40 is 120, and then we would have counted 9 more than we should have, so 111. Subtract that, you get 106. So the measure of this angle is 106, the measure of this other angle is also 106. Number 10, the exterior angle to a triangle is equal to the sum of the two remote interior angles. So the measure of angle 1 is equal to the sum of the two remote interior angles, 36 plus 127. Now, if you forget that, you can easily find x. Add up the two that you know and subtract from 180. So if you add up 36 and 127, you get 163. Subtract that from 180, you'll get 17 for this angle. And then hopefully you'll realize that the one that has a measure of 17 and angle 1 are supplementary because together they form a straight angle. So subtract 17 from 180, you get 163 for the measure of angle 1. So there are some ways to figure that out even without knowing that the exterior angle of a triangle is equal to the sum of the two remote interior angles. Alright, we want to find x, y, and z. One thing I'm noticing is that angle y and 66, those are vertical, so y must be 66. Noticing that, let's see, we've got some vertical angles here as well, so those will be, so this will be 74. Oh, and I notice that angle y, which is 66, is is corresponding with this one, which would be 66 as well. So now, in one of these ways, you've got three angles that add up to 180. So maybe you're seeing it here. So we could say x plus 66 plus 74 must equal 180. Add together the ones that you know, and so you get 140. So x plus 140 equals 180. Subtract 140 from each side, you get 40 for the value of x. And so z is an external angle to the triangle. So now we have that this angle is 40. So you got a triangle here, external angle z, and so z is equal to the sum of the two remote interior angles. So z has to equal 40 plus 66. And so z is 106. We found x, y, and z. And so we're done with that problem. Number 12, angles in a triangle add up to 180. So add the two that you know. Subtract that from 180 to find the missing angle. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So take a look at the slope for each of these lines. So for part A, we've got a slope of -4 as a fraction, -4/1. Part B, we have a slope of 4/1. Part C, we have a slope of 1/4. And then part D, we have a slope of 2, or 2/1. We're looking for the ones that are opposite reciprocals. Opposite meaning it changes sign, reciprocal meaning you flip it. So you hopefully will see that this one has a slope of -4/1, and this is +1/4. Those are opposite reciprocals of each other. So A and C are the lines that are perpendicular. Now, if you can't remember opposite reciprocal, or just another way to think about it is to multiply the slopes together and get -1. So anytime the product of two slopes is -1, then those lines are perpendicular. So if you take the -4/1 and multiply it by 1/4, you get -4/4, which simplifies to -1. The slopes of two perpendicular lines, the product of the slopes of two perpendicular lines is -1. 14, we're looking at the graphs. We want to determine what the slopes are of these and compare them. So look for 2 points where that the line hits the grid marks nicely, and then do rise over run between those points. So if I happen to start at 4, -4, I would rise 1, 2, 3, 4, 5. Go to the left 1, 2, 3, 4. So the slope of line B is 5 over -4. Now for line A, it's the grid marks at -2, 2, and then also at 0, -2. So if we do rise or run between those 2 points, we would go up 1, 2, 3, 4, and then to the left 1, 2, 3. So the slope of line A is 4 over -3. Notice that these slopes are not quite the same. They're close, but they're not quite the same. So eventually these lines would intersect. So are they parallel? No. The reason is because the slopes are not equal. Fifteen, trying to figure out which of these apply to this situation. So I'm just going to kind of go through and try to find the measure of each of these angles, and we'll see. All right, so I notice I have N is parallel to M, so we can assume that's true. So if those are parallel lines, then corresponding angles must be congruent. And so one of the things I can say is the measure of angle 2 is 20. That's not on my list, but maybe we can use that later. I also notice that I have alternate interior angles here. So the measure of angle 4 and the measure of angle 1 must be congruent. And angle 1 and the one that is labeled as 60 degrees are congruent as well, because those are vertical. So measure of angle 1 equals 60. We can say the measure of angle 4 equals 60. We're finding all the ones that are true, so the measure of angle 1 equal to 60 is a true statement. That one I should have used 2 different marks. Alright, so we've got some 60-degree angles there. We've got measure of angle 2 is 20. Now, all three of these angles, 1, 2, and 2, 3, and 4, would have to add up to 180 since they all together make a straight angle. And I know that the measure of angle 2 is 20, and the measure of angle 4 is 60. So if we add the 20 and the 60 together, we get 80. And subtract that 80 from each side, we get 100. So the measure of angle 3 equals 100. So we can say definitively that C is not correct. The measure of angle 3 is not 60. Now the sum of 2 and 3, well 2 is 20 and 3 is 100, so add those together and we see that 120 is correct. And then let's look at 3 and 4. 4 is 60, 3 is 100, so if we add those together we do get 160. So all of these are correct except for choice C. So A, B, and D should all be circled. Notice that it says select all that apply. That means you can have more than one answer included in your answer. More than one of these is correct. All right. We have parallel lines A and B. That's part of our given. And we're told that angle 1 and angle 3 are congruent. All right, because line A is parallel to line B, we can say that alternate exterior angles are congruent. So angle 1 and angle 2 are alternate exterior, so they must be congruent. If you have parallel lines, alternate exterior angles are congruent. Alternate exterior angles are congruent. Then if you look at 2 and 3, well, backtrack. Notice that that angle 1 is congruent to angle 3. Now we have angle 1 is congruent to angle 2. So if we put those together using the substitution property, we can say that angle 2 is congruent to angle 3. Just using substitution. We're replacing 2 with what it's equal to up here. We're replacing it, angle 1 with angle 2 since they're congruent. Now, once we get to where we say angle 2 is congruent to angle 3, those are alternate interior for lines C and D. And so we can say C is parallel to D because alternate interior angles are congruent. So you can expect a proof fairly similar to that on your test. May not use alternate exterior angles or alternate interior angles, but it would be fairly similar. You might have to use corresponding or same side interior angles being supplementary. So hopefully all that makes sense. Feel free to watch it a second time if you need to prepare for the test.